Test, 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 test.
All right, we're going to be starting in about 5 minutes. So as folks are coming in, be sure to double check that your name has your VCS ID prefixed at the beginning. That is going to be needed for the raffle at the end. We're going to be taking attendance, and if folks don't have a number either at the beginning or the end, they will not be included in the raffle. So make sure you do that. And if you're attending any other sessions today after this initial one, be sure you do the same. We are taking attendance on each of these meeting sessions, and folks who are there at the beginning and at the end will be eligible, and you must be present to win the prize. For the session today, we have a $50 gift certificate for sequences from RGB Sequences. So make sure you've got that all set up. Thank you for joining, everybody. We're going to be getting started in about 2 minutes. If you haven't already, make sure you put your VCS ID and your name. We're going to need that for taking attendance for the raffle. So it's critical that you'll have that ID number prefixed to the beginning of your ID name as shown in the participant list to be eligible for that raffle. Okay, everybody, it's top of the hour. Welcome, and this is the first session of today's virtual Christmas Summit. Today we have Ken MacMaster presenting on RGB, I'm sorry, the P5, P10, and Colorlight FPP, and everything that you need to get set up for your P5, P10 panels. Just some conventions for today. If you would, please be sure to put your VCS ID on your participant name as shown in the participant list. That's going to be used to take attendance, and anybody who's in attendance both at the beginning and at the end to collect a prize is eligible for a $50 gift certificate for sequences from RGB Sequences. So make sure you stick around. Ken's got a lot of useful information to share, so it's valuable use of your time. Let's see, here we go. So we are presenting live on YouTube already. The session's set up. And Ken, just some background information on him. He is the owner operator of Wired Watts, if you don't already know. So a little bit more information about his store can be found at wiredwatts.com. And many of the products that Ken's going to be talking about today are also available from him. So take it away, Ken.
Thank you very much, Brian, the great Brian Rudy. I am Ken MacMaster, as he said, owner of Wired Watts. Can everybody hear? Well, Brian, can you hear me okay? Everything sounds good?
Yeah, you sound fine. Yep.
Okay, great. So this is going to be I should have matched up my title on the slide to the actual class, but this is going to be an overview of panels, controllers, how to control them, the things that we use in the Christmas hobby. Obviously, panels are used in a lot of different scenarios in many commercial applications. I'm going to be focusing this on what we do pretty much in the Christmas hobby. So why this class? Well, mainly this class because we have a Zoom room that is for X-Lights, and the main thing that happens in there is people discuss how to use FPP and panels and, trying to discuss the complexity of setting them up and everything else like that. So I figured I would try and do a little bit of a disambiguation of what everything is and how to set it up and the different types of controllers and stuff to be used. And then also, anything can be done more than one way. And so I'm going to show you a bunch of different ways to do things, some ways that I prefer because they work better that way. And then I'm going to show you some other ways that can be, if you wanted to max stuff out. So the overview is, what is a P10, P5, PX panel, common use cases, layout design, control options, and then I'm going to show a little bit of the physical setup and the wiring. I'm going to try and breeze through this PowerPoint as quickly as possible, and then I'm going to try and show you some setup stuff afterwards, and we'll just see what time allots. So what is a panel? Panels come in a bunch of different variations and sizes. The name that you get from it, so if it's called a P5 panel, that's because the dot pitch from between the center of the LED to the center of the next LED is 5 millimeters. A P10 is 10 millimeters. A P2.5 or anything lower than that. That's why it's named like that. So a P10 is 10 millimeters. So you get the picture. Panels come in different variations and sizes. So this one right here that I'm showing is roughly 12 inches by roughly 6 inches. And this is a single color one. This one only does red. As you can see, it's got a whole bunch of red LEDs on it, and that's it. And then they also come in multicolor ones where they've got 2 or 3 different LED dots, and you can see that this one is a different size. This one is probably 16 centimeters by 16 centimeters as opposed to 16 by 32. And then the ones that we typically use in the Christmas hobby are these type right here. They're the full color ones. They're typically SMD 5050, or the P5s are usually SMD 2121. Every dot can be a different color. They come in a bunch of different sizes. Again, typically for our hobby, we use 32 centimeters by 16 centimeters, which is roughly 1 foot wide by 6 inches tall, roughly. It's a little bit more. Use cases, you can use them for tune-to signs. You can use them for giant, panels that display videos and graphics and other things. You can integrate them into props as long as you waterproof them correctly. And then obviously, they're used for signage and other things like that. I've got lots of people that say, hey, we want to build a panel and, we want to use it all year round. We want to, be able to put it in our store window or whatever. So they can be used for just so many different things. They're essentially just, TVs that you get to describe how big they are with lower resolution than a TV. Layout design. Layout is usually in a grid format. So you can see right here, I've got a grid of panels. You can make odd designs such as what's depicted here, where we've got 2 panels that are going horizontal and then one that's going vertical. I'll show a little bit of that later inside of FPP. And then we can also, like right now, I've got this in the horizontal layout. These can also go vertical as well if you want to turn it that way. Here are some different pattern designs. This one right here represents a zigzag pattern where, you have one output on your controller and you zigzag the data back and forth from the panel so it's on one chain. So this is one chain of 6. Here's 3 vertical panels where you can wire them in a way with wires going crosswise to make it vertical instead. Or here's this other odd shape that you can do as well. Layout design in the BeagleBone. So for the BeagleBone, this is a standard grid. With a BeagleBone, you can do, I feel like I missed a slide here actually. I thought there was something that told us some different controller types. Common use cases, layout design, controller options. Yeah, the controller options should be first, huh? That's what I get for doing this late. Layout design of the BeagleBone, anything that's newer in the 2 version of FPP is going to allow you 12 panels per output on a BeagleBone with an octo scroller for a total of 96 panels. That's for a P10. A P5 is 4 times the resolution of a P10. So you're going to get 5 panels per output for a total of 40 panels. And then this is a 8x8 panel. A Pi is going to support, you can typically get a Pi hat that either has 1 or 3 chains on it, or 3 outputs. Each chain or output can support 12 panels of P10s. So you're going to get 36 panels. And then for an octo scroller, you're going to be able to get 5 panels per output for 15 total. And then this right here, you're going to see that in order to get the biggest screen possible on a Pi, I've zigzagged it. So on one output, I've gone like this all the way to the end, gone down and zigzagged back on one output. So this one output is got all 12 of these panels. And then I'm able to do this for output 2, and then output 3, we do that zigzag pattern. All right, panel controllers. This should have gone first. So there's a few different types of panel controllers we can get. We can get something that's completely standalone, like the HC1. There's also versions of the Colorlight card that are completely standalone as well, in which what you do is you've got some software and you upload the sequence to it, and it just runs in standalone and just does what it does when you turn it on. Then we use the Falcon Pi player, or yeah, that's Falcon Pi player base controllers, and that can be a Raspberry Pi, it can be a Raspberry Pi Zero, a BeagleBone, a Pocket Beagle, and then there's also some other types of single board computers that are known to halfway be supported, but for the most part, these are the couple that we use because they're well supported. And then you can get into the receiver cards. The popular one is the Colorlight card, but the Linson card always works as well. I've never used the Linson card. I think there was a reason why I picked the Colorlight over the Linson a long time ago. I can't remember what that reason was, but Colorlights are incredibly popular in our hobby. So here's a standalone computer. This is called the HC1 or the HC1W. This thing has 4 outputs, 4 rows of panels. It's got an SD card slot. No, I'm sorry. It's got a USB slot. And you can get 3 to 12 panels depending on the refresh rate. It's predefined, meaning it comes with a piece of software that you basically do all your stuff on. It's not really X-Lights. It's not X-Lights at all. And so you would just make what you're going to make. This type of thing is typically used in like a store display or something, in which they want to put up their special of the week on there. And so they do it inside of the software that it's provided. They upload it to the USB card, and then it just runs every single time you boot it. So in this situation, you've got the panels directly connected to the ribbon outputs that are right here, and then you plug a USB stick into it, and that's how that works. The Falcon Pi player, which we're going to focus on, you can do it with a Raspberry Pi, with a Pi hat. The Pi hats usually come in 2 variations. It's either 1 output or 3. The 1 output is typically used for a Raspberry Pi Zero. And they usually have, the 3 outputs that are good for 12 P10 panels or 5 P5 panels on each output. And then you've got the BeagleBone with Octoscroller, or the Pocket Beagle with the Pocket Scroller. There's 5 or 6 different Octoscrollers out there. It's been around for a long time. And there's a newer version that's called the Octo Plus. That's something by Dan Culp. That one has got a little bit of different wiring. I'm going to see if I can, there we go, turn them off. The Pocket Scroller allows you, it's got a different wiring diagram. So what it does is it optimizes the amount of panels that you can use if you're using less than 8 outputs. And so it's just a little bit better in that regards. And then we've got the Pocket Scroller. That's also a Dan Culp thing. That's where you're using a Pocket Beagle on top of a board that also has 8 outputs. The 8 outputs allow for 12 P10 panels. So you can, oh, you know what? One of these is wrong. I think this one's wrong. Let me go back and look. 12, maybe it's right. Whoops, too far. Okay. 8 outputs that allow for 12 P10 panels each or 5 P5 panels each. This one has 8 outputs versus the 3 outputs here. The main difference between the two is the BeagleBone is actually a slower computer than the Raspberry Pis for the most part, unless we're talking about maybe the zeros. But the BeagleBone has got some onboard real-time processors as well. And what that allows is for the main processor to just offload all of the things having to do with panel and making the panel signal to those real-time processors. And by doing that, it frees the main processor from having to do the bulk of the work. So when something comes in through Ethernet, or when it wants to go check on the operating system, or when it needs to go update the clock or something, the main processor handles all that stuff, and it's offloaded everything else to those real times to deal with the panels. And that's why the Raspberry Pi has so many less outputs, is because everything has to go over that main CPU for the Pi. And so if we drove too many outputs, it just wouldn't work. There's not enough speed to handle everything. Falcon Pi Player, typical setup. So you can get, and this will work for the Pi as well. You get your E131 or F sequence data that comes in. You can also store it on the actual single board computer as well via the SD card or the eMMC. And then that outputs through the GPIOs to the Octo Scroller or to the Pi Hat, and then out of those ribbon cables into your panels. And this right here, this is showing essentially bridge mode, but where FPP is running and receiving live data from it. If you store it on the SD card that's here, or the eMMC, which I think is that one, I can't remember, or maybe it's this, no, it's not that one. When you store it locally on this, then you don't actually need E131 data coming into it. And that's good for either the Pi or the BeagleBone. FPP Falcon Pi Player with BeagleBone. You can see this is an older screen. I think I did this one back in version 2 of FPP. So it's changed a tiny bit, but not much. And then this is just a typical layout. This grid right here represents this output right here. And that's with a BeagleBone. Here is a maxed out P10 panel with a Raspberry Pi. And you can see where I have gone through here and zigzagged it. You can see right here, all my arrows are pointing up, and these ones are all pointing down, and then back and forth, so you can see that the zigzag is happening. Receiver cards. The Colorlight receiver card has 8 ports. The max resolution at full resolution with full scan rate, whatever your panel is 256 by 256. But their website's kind of funny in that they basically say on special occasions, I don't know if that just means like New Year's and Christmas, that it can also run 1024 by 256, but it's just because you can do it at a reduced scan rate. The Linson receiver card's got 12 output ports, and the resolution's at 512 by 256. Receiver cards. So why do we use these things? Well, they were made for building panels. This is a runway at a panel factory that I viewed in China, and they just had halls and halls and halls of panels like this, and they all had receiver cards on the back side of it. And so they were originally created to do big matrices. They were originally created to do panels. They weren't a hack or an add-on to a single board computer that was made to work. So therefore they are faster. They're going to be faster than a Pi, and they're going to be faster than a BeagleBone. And therefore they're going to give you a better refresh rate and a better overall picture. And right here you can see that I've got picture, this is an outdoor cabinet, and these things are linkable. And so each one of these squares here represents one of these, and in each one of these is a a power supply and one of these receiver cards. And then what they do, if you see the little blue and the white here, is they uplink power back and forth, and they also uplink data as well to create these very large matrices, and that's what the Colorlight can do. Typical design and layout for a receiver card, the intended setup, and you can't really see this, I forgot to change the color. It says HDMI or DVI source. So the typical setup for a Colorlight card and what you would typically see right here and how these things are run is you've got a sender card where you send it some sort of video source, an input, and then what it does, it's got these Ethernet or Cat5 outputs. It's not actually like really Ethernet. It's not routable TCP/IP anyway. It outputs from here to the Colorlight card, and then these things daisy chain back and forth and output to these things. This is the intended setup. This is what are used when you build giant matrices for this type of thing. The way that we do it for our hobbyist way, because these are expensive, is we do it with, again, I should have changed the color here. It says E131 and F sequence data. We do it with a Raspberry Pi and the Colorlight. And so a typical way to do this is to either receive live data in bridge mode, or we write our sequence directly to the SD card on the Raspberry Pi, and we let this thing run in remote mode where it's receiving a sync signal from the show player. If you're using a 3B Plus or a 4, they have a gigabit card on it. If you're using an older version of a Pi that doesn't have a gigabit, you can always go get a gigabit adapter to add it, because the Colorlight cards, they need a gigabit adapter in order to read any signal. You can also bypass getting this if you go from your output into a gigabit switch and then back out here. But in order to initially configure this receiver card, you have to have it directly connected to a computer with a gigabit connection. So you're going to need a gigabit connection somewhere in order to make this thing work. But again, typical output, you can go output from X-Lights or LoRa or whatever your E131 source is, come into the FPP as live E131 data, and then it will output through gigabit to the Colorlight card in the Colorlight protocol, and then from there it will output out to your panels. This I included, but we just shouldn't use it yet. Scott Hansen, he's a great contributor to Everything Christmas over on our boards. He wrote a piece of software that is still kind of buggy, that allows you to transfer, you essentially have the E131 data come out of the X-Lights to a loopback address, and then this piece of software that runs in the background will translate the E131 data into Colorlight data, and then blow it out your network port to your Colorlight card, along with whatever E131 data that needs to go out to the rest of your show. It works. It's buggy and it crashes sometimes. So I would stay away from this at the moment, just because you don't want to have something running and it crash. But it is out there, it's available, and it's open source. So if you feel like improving it, you're a programmer, go for it. Why use a standalone controller? So back to the little tiny H1, whatever it was. You power it on and it works. You just turn it on and you immediately start seeing, whatever the output should be. The con, it's offline, so you can't just talk to it. You can't hook up to it. And I'm specifically talking about the small controller that I showed. There are other things. I know Colorlight also sells a Colorlight card that allows for both live data, and it also allows for offline data as well. But again, those are more money. They're not really supported in what we do. So the con, they're offline. You write your sequence, you go plug it into the thing, and it just runs. They're predefined because it uses the specialty software. Why use FPP? Because you've got lots of options and lots of configurations that you can use. You can use it in bridge, standalone, or remote mode. There's a ton of help and support on the groups, especially the Zoom call. That Zoom call is pretty much dedicated to FPP. The con, this is old, it says SD corruption issues. We've pretty much gotten over that at this point. The version 3 and 4 versions of the software have gone away from that. The other con is it's complicated. But once you get it set up, the complication goes away. You know, typically what we do with these things is you get a configuration that works. Once you get a configuration that works, it's not like you're going to be rebuilding your panel all the time. So you pretty much just leave it, you know, export the configuration so you can use it later, or screenshot it, or whatever you do. And once you get it working, now all your work is done inside of X-Lights or your sequencing software. Why use FPP with a Pi? It's simple, and you can get a zigzag configuration. The con is the number of panels. Not all the panel types are supported. The lack of the real-time causes ghosting and tearing. I never recommend a Pi to anybody. Whenever they say they want to build a panel, I say either go with the BeagleBone or go with a Colorlight. I only recommend a Pi if they say, well, I already have a Pi and I just want to use it. I say, okay, well then a Pi hat will do it. But other than that, I don't ever recommend a Pi, just because it does lack the real time and not all the options are supported. Why use an FPP with BBB? You're going to get bigger panels. It's got those onboard real-time units to drive the panels. You got more panel types and refresh rates that are supported. You don't need an SD card because the BeagleBone has, and I'm specifically talking about the BeagleBone Black. There's a few different variations of BeagleBones out there. Not all of them have it. And the Pocket Beagle does not either, but the BeagleBone Black has what's called an eMMC. And what that is, it's onboard storage. It's 4 gigabytes. You can store your operating system on it, and then you can store some sequences on it if you stay under that 4 gigabyte limit. You can leave the SD card in it for ease of setup, and you can store everything on your SD card as well. Your SD card can go anywhere from, I think it's, 8 gigabytes up to probably, at least 128. I'm not sure what the limitation is on that one. And maybe Brian Rudy will correct me on that one. Con, it's more expensive to do a BeagleBone and Octo Scroller or Octo Plus setup. And then tearing. Again, so I always say Colorlight is greater than BeagleBone is greater than Pi. Once you get to 12 panels, I always send you over to the Colorlight card. And the reason for that is once you start doing a lot of graphics and a lot of other things on it, it's going to start giving you a rippling or tearing, an artifacting that you're going to see on the screen, just because there's just so much data going over the lines. And the BeagleBone can get pretty close to what a Colorlight can do in speed, but the more panels you add, the more stress it puts on the processors, and it just can't keep up with the refresh rates that the Colorlight can do. So why do we use a receiver card such as the Colorlight? It's designed to do this. It's got an FPGA on board. You get better brightness and colors out of it. Anytime you run a Colorlight card versus an Octo Scroller, the power consumption essentially doubles because you're getting a much better refresh rate. And so the panels are on longer. Remote configuration. So this stems from, typically I don't, and Bill Porter will agree with this one as well. I don't like to put an SD card out in the middle of my yard. I like to have the show player somewhere accessible where I don't have to get on my knees and dig inside of a box and possibly drop an SD card in the grass while I'm outside at night with a flashlight. When you do a receiver card, you can lock the receiver card into your enclosure, and you can run a Cat5 cable to it and store your Pi in the garage or on your desk or wherever it is. And that's going to allow you to have a better configuration, because you don't have to open up the back panel, because once you build your enclosure or whatever it is, you're going to seal it. And it's going to be hard to open it up and get things out. You don't ever need to access the Colorlight after you've configured it. Most all panel types are supported. I mean, obviously not all of them are, but a lot of them are. And definitely everything that is pretty much sold to hobbyists. The con, it is extra hardware, and it's definitely more complicated to set up and use than FPP, because of this situation, you do have to configure the Colorlight card, and you have to configure FPP because you need to run it with a Pi if you're not running the buggy software. Physical setup, this is my failed attempt at taking a picture of what a panel looks like on the backside. But as you can see, this is a 2 wide by 3 tall panel setup. What I've got, this is a BeagleBone with an octo scroller sitting on top of it. I'm using a total of 3 output chains because it's better to use more output chains than less. And each output chain is going to the left side. Whenever you're looking at the back side of the panels, typically if all arrows are pointing up, you're going to be data input on the left side. So each one of these outputs goes to the first panel in the chain, and then the chain is daisy chained across until you get to the end. And then I've got a power supply, and it's not showing connection, but you would have all these input connections on the back for power. And those would either run directly to your power supply, or you could run a fuse block in between. So I've got, it says questions here, but what I'm going to do is I'm going to close this, and I'm going to head over to FPP. Actually, let me go through and look through these questions really quick and see if there's anything we need to talk about. How about closing Facebook? How many panels can a Pi Zero control? I'm not sure. I can't remember. Pi Zero typically uses a bonnet that has just one output, but I believe it can control the 12. But don't quote me on that. I don't know if Brian Rudy knows the answer to that. Maybe he put it later here. Pocket. Go ahead.
Yeah, just gonna say I wouldn't do any more than 6. That's pushing it already for a Pi Zero with P5s.
Yeah, the Pi Zero's got a much lesser processor than any of the other stuff out there. Pocket Scroller has 6 outputs. Thank you for the correction. Does the scan rate limit the number of panels, outdoor panels? Yeah, so the P5 indoor and outdoor have different scan rates. And you can see here in the FPP window here, and you'll see most of them say, here's the P5 ones. They're 64 by 32 pixels. So you can do them at 1/16 scan or 1/8 scan. The indoor ones are going to be 1/16, and the outdoor ones are 1/8 scan for the most part. Depends on your manufacturer. Does the scan rate limit FPP, remote mode, local sequence wirelessly gate to Colorlight? Yes, with FPP and remote mode, you can do wireless to get your sync packet if you want. I hate wireless inside of a display. That is my personal preference. I pretty much hate wireless, period, because I think it's unstable. If you talk to Dan Culp, he only does wireless. He doesn't use Cat5 cables for anything. So it is definitely a preference and a choice. The wireless cards on single board computers that are built in are typically not great because the antenna is too small and it's stuck inside of a whole bunch of metal and electromagnetic interference. So you usually don't get very much range off of them. So if I was going to go wireless, I would probably add a wireless card to it so I could get some range out of it. And the other thing you got to think about too is, you know, the first year I started building stuff, I put an FPP inside of a Megatree, not thinking that I'm essentially putting an FPP with a wireless inside of a Faraday cage. I've got giant, you know, chutes of copper going up, you know, all around it. It's not going, it's going to block that wireless signal. So you got to be careful about running wireless in your display. Definitely can be done. I would go external wireless card though. Cool. My panel. How is your remote mode? Where can we find the E131 Colorlight software? I might have it. I'm not trying to shamelessly plug here. I might have it over here. I don't, but this is an old
I can
video.
put a link in chat.
You got a link? Okay, great.
Yeah, I'll put a link in chat.
Okay, great. It is open source. It's on Scott Hansen's GitHub. And so you can definitely go download it and compile it or whatever. How about Pi with Colorlight? That's what we were talking about. Use 2 Pis with a whole bunch of panels. I think I caught up on most of here. Are there any other questions? Does anyone want to unmute themselves to ask any questions before I start going over this piece?
And if you attempted before, now you can unmute.
This one says how many amps they use. I did do a check on, I think it was just P5 panels. And again, so a P5 panel tested with a BeagleBone and Octoscroller is going to use about 1.6 amps or 83 watts when you do full brightness. And that's with me hooking up 2 panels and putting a DC clamp on it to check it, where it used a lot more when we used the Colorlight card on the same brightness. I didn't check the P10 panels. I didn't check the outdoor ones. The outdoor ones are going to take a lot more power anyway because they're much brighter. They're meant to be, seen in daylight, on your McDonald's sign or your digital billboard or whatever. Good point. Daisy chain. Can a daisy chain Colorlight configure more panels in FPP? Yes. With Colorlight cards, you'll see, and I'm going to go back to the website again here. On the Colorlight, you'll see it has 2 input channels, or 2 Cat5 jacks anyway. And you can use them, either one for either thing. So you can go into one and out the other, or into this one and out the other. But you can daisy chain these things to make much bigger panels. And the way that we do that is inside of the FPP software, you would go in here and select Colorlight, and you would go say that I want something that's 12 wide by 8 tall, let's say. And I don't like the front view. I like looking at the back. There we go. Okay. So in this situation, actually, this is 12. In this situation, I would run 3 Colorlight cards, because if I'm talking about a P5 panel, I know that I've got 8 outputs on it. So my outputs would be, this would 1, this would be 2, 3, 4, 5, 6, 7, 8. So here would be your 8 output channels. But to be in that 256 by 256, you're going to be able to get 4 wide by 8 tall. And that's going to be the full refresh rate for one Colorlight card. So I divide this thing into 3 sections and put one here on this 4, and then start another one right here for this 4, and then a third Colorlight for this 4. Now, the Colorlight can support wider configurations, but only at a lower scan rate. But what you would do is, inside of the FPP software, is you configure it all as one giant matrix, and then you would do it differently inside of the Colorlight software, and I'll show you that in a minute. How many Colorlight cards can you daisy chain it to a Pi? I know that the official answer was 2, but I don't actually know what that answer is. I bet you it's as many as you want, or that the Ethernet jack can handle to output.
I believe it's 3, Ken.
Is it 3 now?
I think so, yeah.
Up to 3. It conceivably could be more, but I think we've only really tested past 3.
I was going to say, is it we only tested 3 because the Pi doesn't really care what it's outputting as long as it's just outputting, right?
Right,
It
but
doesn't. There-
yeah, it was
there's
just
a
tested at 3.
specific
That was it.
format.
Okay.
Yeah, there's a specific formatting that you need to do to address individual cards, and I think we only have reverse engineered up to 3 cards. It conceivably could support more, but given the total pixel count or channel count, that means that's a lot of channels.
Yeah. Okay. How many color lights can you daisy chain? So the answer to that is 3. Yes, you would turn down the brightness and what colorless power. Okay, so I will go. So this is, I'm going to go set this back to 1:1 just so we can show this. So if you boot up your Raspberry Pi or your, oh, this does say Pi on here. Do I have another one connected? This is a BeagleBone. What is going on here? Oh, it's picking up the wireless to something else. This is funny. Okay, hold on one second. I'm going to go do something on the back end. I was talking to a BeagleBone a minute ago. Okay, here's the BeagleBone. So when you boot up a BeagleBone in version 4 of the software, you're probably going to get a screen that looks like this. You can go into, what I always do personally is I go into storage settings, and it's a one-time only thing when you boot it up because you either grow the file system or you flash it. I always hit this flash button, and this copies the whole operating system to the BeagleBone. And that way, you don't need the SD card anymore to turn the thing on. I'm not going to do that right now because it takes a while. But if you go to your channel outputs and you go over to your LED panels, this is going to be where you configure your panel size. So later on in the build today that I'm going to be doing, I'm going to make one that's 2 wide by 3 tall. I'm going to be using a BeagleBone with an octo scroller, and I'm going to configure it so the top row is output 1. So, and again, I don't like to view it from the front. This is panel 1. This is panel 2. This is output 2. This is panel 1, and this is panel 2. Again, this is output 3, panel 1, panel 2. And what I've done is on the back of the panel, and I've got one here I could show you. Let's stop share. Who else is sharing the video here? On the back of, where's my camera? On the back of panels, you're going to see that they have arrows, and the arrows are usually pointing up and over. If I'm looking at this from the back side, this is going to be my input, and I don't know if you can see it or not, but it should say J in, and then on the other side, it's going to say right here, it's going to say J out. So again, let me get back to my other screen. And I want to share this one. You're going to see that all of these arrows are pointing up. I like to point all of my arrows up, keep them all in the same direction. If you were going to do a zigzag pattern, you click on them and you can make them go down. The reason that I like to keep them all up, and I like to keep them on as many chains as possible, is because you're going to get a better refresh rate by doing that. So in this situation, I'm using 3 chains instead of zigzagging. If I wanted to zigzag, what I would do is I would put this row up, this row down, and then this row up again. And then this would all be on output 1. And these would be labeled 1, 2, 3, 4, 5, and 6. And this would allow me to have just one output and zigzag them back and forth between so that the data goes through everything. I don't like to do this because what that's doing is it's putting a lot more pressure to get a lot more data out of one channel as opposed to sending data out of multiple channels. This will also allow you to do advanced layouts as well. So you can come in here and we could maybe move this over here and rotate it and pop it to the end like this. And as long as you come in here and say how it's gone through, so I'd say this is 1, maybe this is panel 2, and then we're going to go out to panel 3, and this is output 2. And you can go in here and rearrange things in a different, more advanced way. And then what will happen is the BeagleBone will process that, reverse it, and change the orders of everything in real time as it receives the data to output to these things. So if you want to do more advanced layouts, this is the way that you would do it. I am going to uncheck that box because we don't use it. Let me go over, so up here, you've got your width of the panel. You're going to go in here and describe your panel as well. So if you're using P10 panels, typically you're going to be using a 32 by 16 with an 1/8 scan, okay? If you're going to be using P5 panels, the indoor ones, typically you're going to be using a 64 by 32 with a 1/16 scan. I always leave this at top left. Here's where you adjust your brightness. This goes on a scale from 1 to 10. So this is 70%, 60, 50, whatever. I typically like to run these things on 70% myself. You can pretty much leave the gamma alone. You can adjust this. I know that I have adjusted it in the past because I had a graphic of Santa and I was able to make his pants look a lot more brown by adjusting this up or down. I can't remember what direction. Your bit depth, for all intents and purposes, for what you're going to be buying from anyone, is most likely 8-bit. If you're using a octo scroller or a pi hat or a cap or whatever, you're going to have it set to this thing here. Your start channel, this is where we have lots and lots and lots of confusion. So right now it's just set to 1 because that's just the default setting. And it's telling me, because I put in that I have 64 by 32, that I have this many pixels that are going to be going from whatever my start channel is to the end of this. And I'll show you how to reconfigure this in a minute. The default panel color order is RGB, but most of the time it, I believe it is BGR, actually. Where is it? BGR, last one. I believe that's the one that you typically find. And how you do that is you would go into, if you set it to RGB and you go over into your display testing, you would just go tell it to do a fill of red. And if the red is blue, then you know the two are switched and you just go back and switch it. But that's how you determine your color order. The wiring pinout. So the wiring pinout that you get for an octo scroller, this only matters for BeagleBones. You won't see this on a Pi because there's only one wiring pinout that we use. With a BeagleBone, you'll see this if you're using an octo scroller. If you're using one of the newer octo pluses, you're not going to see this because he's got an EEPROM on there and it's automatically going to set it to 2. And I don't know what this is. This came along later, but usually when something doesn't look right, we check this box and it checks. And I'm not sure what this is. I haven't done much research on it, but if everything else looks right and in the settings, we check that box and sometimes it fixes it. I'm not sure why. Connection. If you are running this for a Colorlight, now typically we don't want to run a Colorlight with a BeagleBone. We want to run it with a Pi. So you would go in here and set this to Colorlight, and a few of these options change here, but basically you're just going to go configure your whole panel here. And this is also going to say what interface you might have, a USB connection or an Ethernet connection to it. Mine would just be ETH0. I'm running out of time here, so let me just go quickly open up the Colorlight software so we can show you a couple things in there as well. This is version 5 of the Colorlight software. To do anything with it, you would go into screen control. I'm going to set this up for, again, my 2 wide by 3 tall. So what I'm going to go in here, I believe this number, yeah, this is, if you look right here, the X and the Y, this is just what this is right here when you move it around. But what I want to do is I want to go set this. I'm going to be doing 2 panels wide, which is 64 times 2 is 128. And then I'm going to do the height of it is, it's 32 pixels tall times 3 is going to be 96. I hit apply there. And this is the size of my panel on this screen. So then we go into the LED screen settings and you type in the magic password, which is 168. And you would hit detect receiver card. I don't have any receivers cards connected at the moment, so I'm not going to do this. But you would go into here and you would set up your, I usually like to go in here first. If you go select this, you click on it, and this is gonna say, this is one Colorlight card. So if you only have one Colorlight card, you click on it, and you're gonna say, my width is 128, by my height is 96. You gotta make sure that when you click on this, that it updates over here. And when that does, you hit save to receiver. There's 2 save buttons. So you wanna go do this one first. You hit save to receiver, and now it knows how many Colorlight cards. If you've got more Colorlight cards, then you would say, maybe you've got 3. You would go in here and you would define what's connected to the Colorlight card, not the overall panel. So in a situation where I would be doing 4 panels wide by 8 panels tall, I would select this and I would type in 256 by 256. And these are my pixel counts connected to that Colorlight card. Then I'm going to go to this one and I'm going to say the same thing. I want 256 by 256. Same for this one. So what this does is it sets up your grid and your daisy chain grid. Once you have this set up, you go down here and hit save to receiver. And what that's going to do is it's going to save the config to the receivers so that it knows to run in that chain. When you have 3 Colorlight cards or 2 Colorlight cards chained together, there can't be anything in between. It basically, you can't put a switch or anything, you know, any one thing off this side, one thing off the other side. And at the end is not an uplink port to more Ethernet data. It is a different protocol. It does something different. So you're going to go out of your sending device, which is typically a Pi. You're going to go into this first one. You're going to go directly out of that one into the next one, and then directly out of that one to the next one in that order. And that's going to create your matrix. So the Colorlight cards know how they are arranged on the grid. In this situation, what I'm going to do is once I save this to my receiver, when I come back over here, I'm going to go tell it how big the whole entire thing is. So 256 times 3 is 768. So I'm going to go put in 768 here by 256. And that's going to give me a crappy refresh rate. This says the whole box setting. Maybe this is wrong. Rudy, am I wrong on this one?
No, that's right.
Okay. So maybe it's because I haven't saved it because it's giving me a, oh wait, you know what? I'm gonna go load my, so if I'm gonna use 16 scan panels, I'm gonna go grab to load and preset parameters and go into the generic full color. And I'm gonna go find full color 16 scan. There we go.
Ken, one quick thing, just to time check, we're at 52 minutes past, so you got about 8 minutes left.
Okay, you're doing a raffle too, right?
Yeah, that won't take long, but if you want to wrap up with any further questions, just make sure you leave time.
Okay, so I'm gonna go set this back to this really quick, just so we can show it, and make this 256. And once you hit save on this guy here, and once you hit save on this guy here, it should all work. You can also run through the intelligence setting here. I don't have one connected, so there's not much to see, but this will go through intelligence setting. And we could probably do that at some later point in time. So let me let me go through and take any questions. I see that there's 13 new chat items since I last looked. What's the password? The password's 168. Linson, MAC address, and FPP working correct yet? I don't know much about the Linson cards. I've never used one before. I know there was a reason why I chose to get on board with Colorlight in the beginning. I can't remember what that reason was. I think it was because there were a couple of issues here or there. And it seems that Colorlight is pretty much what's been ubiquitous across, or what the whole community has chosen at this point too. And which LED version should you use? I'm going to recommend version 5 because it works. It doesn't have any of the weird graphic stuff that the later versions have. Pretty sure there's a YouTube video about brown being a weird color. Yep. Why not run Colorlight with a BB? Why only on a Pi? Well, the easiest way to say that is the Pi has a gigabit adapter nowadays. The BeagleBone Black does not. There's that issue. You would have to go out to separate hardware. But we've seen it where it staggers and can't keep up, and it creates artifacting on the Colorlight card. So it's typically just not recommended to use a BeagleBone. Any special setup to daisy chain? I think I've covered most everything. Is there any other final questions? I'm going to stop sharing my screen, tap on video. Are there any other final questions on anything? You guys can unmute yourself if you want. What type of panel is used behind me? That is a, which way do I need to go? This way. That is 1 tall by 5 wide, and I absolutely love that configuration. I made that for Expo last year, along with a whole bunch of other ones, and that one was my favorite one out of all of them. What are the passwords for LED software? It's 168. It's a P5, yes. So P5 and P10s, just a quick overview for that. Ricky Cloutier, he's got a gorgeous display. I went and visited last year. He's got this giant P10 panel on his roof. I believe it's 8 wide by 8 tall, which is roughly 8 feet wide by 4 feet tall. It's more than that, but roughly. At a distance that we were standing at probably 50 to 75 feet, it looked like an HD 4K monitor. Because even though the dot pitch is really far away, when you're close up to it, the farther away you get from it. It's kind of like going to Best Buy. If you go to Best Buy and you're standing 100 feet away on the other side of the place, you can't tell the difference between a 1080 screen and a 4K screen. But when you're right up on top of it, absolutely, you can tell. So when people ask me a lot of times, do I need to get a P5 or a P10? I say, how far away are you standing? And that's typically the deciding factor. The billboards that you see out on the freeways are somewhere between a P10 and a P20, just to give you a frame of reference. And those things always look pretty high def because of the viewing angle that you're at. P2.8 panels, they're available. I don't have any. I haven't stocked any yet, but you know, I can definitely get them. I know many different panel places to buy from. Is it not recommended to winterize indoor panels for outdoors? So when it comes to outdoor panels, your outdoor panel is going to be waterproof on this side, this side, this side, this side. It's going to have weep holes in the bottom, and this side's going to have a covering on it, like a little bit of a gel coat or a covering to it, but it's not waterproof. So this side here gets gasketed up against a piece of sheet metal with, I think it's 12 or 16 screws, and then there's a rubber gasket that goes all the way around it. So in either situation of indoor versus outdoor, you have to have an enclosure to take care of your power supply, your computer, and then the back end of that panel. So a lot of people, they just buy the indoor ones and they put it out in the winter. I would put weep holes on the bottom of it, depending on where you are, so the condensation doesn't get stuck inside. I've seen some panels that are pretty bad. They got rusted out and the LEDs were falling out of it because it just wasn't built well and it wasn't weatherproof well. So that's all up to you on that one.
Hey, Ken, we're at 2 minutes to the end. I want to make sure we get time to do the raffle.
Okay. Well, I'm going into my next Zoom after this to do the build. So if you guys have any questions, that's going to be more of an open forum. So if you have any more questions, just ask there, and I'm going to let Brian take over the raffle piece.
All right. Give me a sec. Bother. Okay, stand by. Okay, everybody, we're going to start the raffle. We took attendance during the course of the session, so all the numbers were entered for those folks who were here at the beginning, and we'll double check and confirm that folks are still here at the end. So let's do it. And looks like the original one here looks like he's already won a prize. So the next one up, Keith Ratliff, VCS ID 1872. You win a $50 gift certificate for sequences from RGB Sequences. Congratulations. All right, everybody, that is it. We're at the almost at the top of the hour. If you want to stay in this room, Ken's going to be doing a build session for some panels, and probably if you have further questions, we'll kind of roll into that session if you want to. We've also got several other sessions going on or getting ready to start. So thank you for joining, and thank you, Ken.
Thank you, guys.
Brian, I got a question. On the raffle, if you lose connection during the meeting and reconnect, does that drop you out?
You'd still have the same number as long as you're here when we took attendance at the beginning and you're here at the end.
Okay.
Hey, Brian, are you host on the next one or is somebody else?
I am. Yeah, I'm hosting the next one as well.
Okay, I'm going to drop off of this one and I got to go reconnect with some different computers.
Yep, no problem. For folks joining in, Ken will be right back. He's switching computers for the build session, so stand by. And if you haven't already, be sure to add your VCS ID to your name. We are going to be running a raffle for this session as well. And you're going to want to do that because it's a $50 gift certificate from Wired Watt. So this is one of the good ones. right, can you about set up? You have audio yet, Ken?
Working on it. Can you hear me?
Yep.
All right, I'm going to go get on a third computer really quick.
Okay. And just a reminder for anyone who has joined after I made the last announcement, be sure to put your VCS ID in your name. We are running a raffle during this build session as well, so we'll need that to be in your name to take attendance to be eligible for the raffle. And you will need to be present at the end when we do the raffle draw to win.
Okay. I am going to start. Let me see if I can pull up. Great. Are we ready to start?
Yeah, if you're ready, I'll give the intro and we can get going.
Okay, go ahead.
All right, thank you everybody for joining. This is a session for building a P5, P10 enclosure. Ken's going to be actually doing this live for everybody to see. We're also going to be having a raffle during the course of this session, which is a $50 gift certificate from Wired Watts. So be sure to hang in there and make sure your VCS ID is in the name in the participant list, because that's what we're using to take attendance, and you need to have your number in there and be present both when we take attendance and at the end of the session to win the raffle. So be sure to have that in place and stick around. Just a little bit of information also as well. Ken, I don't know, do you want to leave it on unmuted so folks will be able to ask questions? Because I know you're going to have your hands busy, or would you prefer to hold questions off to the during dedicated times?
I am sitting at a computer at the moment, and I'm going to go through a couple of things that have to do with setting up FPP. And once I get through that, yeah, we can unmute everyone and just go free for all.
Okay. So in those spans of time when Ken is talking, I'm going to basically lock out unmute, so you won't be able to unmute yourself. If you do have a question, type it into chat or hold for when Ken opens it up for questions. Just a little bit of information, if you don't already know, Ken is the owner operator of Wired Watts, who's also the sponsor of this session. So Ken is a very knowledgeable guy about all things P5, P10, and matrix panels. So be sure to take advantage of his availability to ask questions as we go, and hope everybody has a good time. Let's get started. Off to you, Ken.
Thank you, Brian. Okay, cool. So this is I better hold on. I gotta go turn off the audio. Echo is going to drive me insane. What I'm going to do first is I'm going to share my screen. This one here. And if you, let me close out these couple of things here. if you go to